Hello back. Today we're going to be talking about amines and amine chemistry. And we're going to start by first talking about the rules of nomenclature associated with amines. In the case where you have a single chain given to you, and this particular chain contains nothing but just a regular alkyl, it could be branched, it could be cyclic, but it should just be a regular alkyl attached to your nitrogen, you can basically go about naming this thing two ways. There's the IUPAC way, which basically names this the same way you would name an alkane. This has 4 carbons, so that will be called butane. But you simply drop the E letter of butane and replace it with amine. So this is butanamine. Alternatively, you could always treat the alkyl chain coming out of nitrogen as a substituent, really. So you could just call this butylamine, and both of these two types of naming are applicable. Obviously, the common name is a lot simpler to go with, and oftentimes you'll hear people just refer to amines using the common name for the most part. There'll be a few situations, more complex situations, where it'll be better to use IUPAC, but the common name is very much the way to go. So if you name it the IUPAC way or common ways, technically you're okay, but just be aware of the common name being a lot more commonly used than the IUPAC way. If you do have multiple chains attached to the same nitrogen, like in the case shown right here, then it's probably best that you name this via the common way. You could still use IUPAC, in which case you have to select, which chain is the longest one, which in this case happens to be the cyclohexane chain. So as far as naming this thing, you'll say cyclohexane, you drop the E, replace it with the word amine. So it's cyclohexanamine. And then you have a butyl chain that's connected also to nitrogen. So you have to specify that by saying that butyl is bound to nitrogen. So you say N-butyl cyclohexanamine. But as I mentioned just in the previous example, it is probably better to just go with the common way of naming amines, which is just to treat the two alkyl chains as substituents. And so you just list them alphabetically, butyl first, cyclohexyl second, and then you end the naming by saying amine. So butyl cyclohexylamine tells you the whole story. And notice that each time you have as many hydrogens on nitrogen in order to end up with 3 bonds, right? So it's not like carbon that you want 4 bonds, you only want 3 bonds. And to be technical, each of these nitrogens has a lone pair on them, even though they're not being drawn. So you have to be ready to acknowledge that, especially when it comes down to mechanisms. All right, so like I said, the common way of naming amines in this scenario with multiple chains is the preferred route. And when you have multiple chains of a kind, then I would say, yeah, absolutely. Probably the common way is the way to go. So much so that I'm just going to go via the common way on this one. I'm not even going to bother with the IUPAC. Notice that you have 2 ethyl chains on this molecule. So you can say diethyl to emphasize that little um, fact associated with the molecule. And then you have a propyl chain also sticking out, right? So you just have to name them alphabetically. Ethyl first, propyl last, so diethyl propyl amine. And so that would be the way to go. Now, there's one exception, so to speak, when it comes down to naming the amines, in terms of, choosing almost always the common way as opposed to the IUPAC way. And that is if you actually have other functional groups. A molecule like the one you see right here, in addition to having the amine functionality, here we happen to have a nitrile and we happen to have a ketone specifically. Now, both the nitrile and for the matter the amine group are now treated as substituents in the presence of functional groups of higher order, and pretty much nitrile as well as amine are at the bottom of the priority list, right? So if you have anything else, aldehyde, ketone, carboxylic acid, ester, alcohol, yeah, the amino group is automatically just completely demoted to just being a substituent. So the way you would go about naming this is, locating the longest chain like you normally would, and yeah, you follow the IUPAC name for this thing. But now the functional group is not the amine; the functional group is the ketone, and that's why I'm labeling this thing, numbering these things from right to left, because that will allow me to yield the ketone the lowest number. So this happens to have a total of 8 carbons in the chain. So at position 5 we have cyclopentyl, at position 7 we have cyano, at position 6 we have a methyl, and then at position 4 we have the amino group. And so we basically list them alphabetically. So here it is: 4 amino, 5 cyclopentyl, 7 cyano, 6 methyl, all alphabetically, and then you end up by naming the parent chain, which is 2-octanon. All right, so that's how you treat these situations. And yet here you have no choice. You have to use the IUPAC way, because yeah, it would be a nightmare trying to name this the common way. And technically, yeah, it wouldn't quite work, because you will still have to give priority to the ketone as opposed to the amine. All right, now with that said, there are some amines that do have a very specific common name, which there's just no way around this issue. You just have to memorize them. And there's a lot of them, but I'm going to highlight the ones that I think are important. Like, you've seen them in the past. Some of them you're going to see right now for the first time, but you'll encounter them a couple more times in the near future. So the first one is this benzene derivative, where one of the carbons in the aromatic ring has been replaced by nitrogen. This technically has 3 bonds on nitrogen. You do have a lone pair on that nitrogen, and it's known as pyridine. And I've used this molecule a number of times in the past to use for the purpose of removing protons, which, is basically, one of the main uses of it. It's not the only one, but it's one of the main uses of pyridine. We'll have also a 5-member aromatic derivative, where one of the carbons here is replaced by nitrogen. And because that nitrogen has a lone pair, it completes the conjugation, making this ring aromatic. This molecule is known as pyrrole, and I've mentioned this once or twice during the aromatic topic. But you also have the non-aromatic derivatives, the 6-member ring, no double bonds. So this is technically a secondary amine. You only have 2 connections to nitrogen, whereas pyridine had 3 connections, so technically was a tertiary base. So this one right here is known as piperidine. And likewise for pyrrole, if we remove the aromaticity altogether, right, get rid of those double bonds, we still have that secondary amine, but this now is called pyrrolidine. And we've used both piperidine and pyrrolidine in the past for the Stork enamine synthesis, and yes, enamine synthesis in general. So you've seen them in the past. I haven't highlighted the names all that much, perhaps, but now you're introduced, formally. So say hello. Okay, and then there's some extra aromatic amines that you should probably have or be aware of. The first one is a derivative of pyridine, where now you have 2 nitrogens on the ring, and they're separated by 1 carbon. This one is called pyrimidine. And another one, a little bit more complex, you have technically a bicycle in this molecule. It's a bicycle molecule that happens to be aromatic and contains 4 nitrogens within it. This molecule is known as purine, and the reason why I'm highlighting these 2 in particular is because these are the bases associated with the building blocks of DNA. So you might have recognized them the moment I show them, maybe not, but yeah, this is why I think it's important to know these names, right? Especially if you go into biochemistry, you'll be referred to, like pyrimidine bases, purine bases, and yes, this is the backbone of the actual structural features of those DNA bases. And also, kind of taking that approach, there's a couple more, like this 5-member ring, also with 2 nitrogens separated, by a carbon in the middle. This is known as imidazole. And this one, although it's not a ring, does have some significance in biological systems. This is a urea derivative, technically speaking, where instead of having oxygen here on the top, we have a nitrogen and an H. As such, this is known as guanidine. And both imidazole and guanidine are present in proteins. They're side chains, technically speaking. So they get involved in structural features of proteins as well as the acid-base chemistry that proteins sometimes catalyze. All right, and one last thing, as you're going to find out pretty soon, it is very much an option for the nitrogen, which does have a lone pair if it's neutral, to act as a base. And as such, you can protonate it. You could also alkylate it, but now you have this cationic component. And so you have to kind of treat this as an ionic compound. And it is, in essence, an ionic compound, but you still have a moiety that is totally organic. So you have to name this as if it were an amine, except that we're just going to treat these cationic versions, the conjugate acid versions of amines, as ammonium. So this thing, we simply look at the substituents and say, well, that's isobutyl, this is isopropyl. So we name those two alphabetically, isobutyl, isopropyl. And then you say ammonium, not amine, ammonium specifically to emphasize that this is the cationic conjugate acid version of the amine. And because it will have a positive charge, there will always be something with negative charge to counteract uh, the charge of the ammonium. So you have to list that anion last. Here happens to be chloride. It could have been something else. It could have been bromide, could have been sulfate, could have been many other things, as you're about to see. All right, here's another example. Here we happen to have three chains of a kind, specifically ethyl, three ethyl chains. So this is simply referred to as triethyl ammonium, and because we have right here chloride as the anion, we end up with the word chloride. But you could have something a little bit more funky, like fully organic, if you will. So for instance, the molecule right here, this is derived from pyridine. So you don't call it ammonium, right? You have to kind of go based on the common name, pyridine, but now you add this word ium, kind of like what you do with ammonia, ammonium, pyridine, pyridinium. And then notice that the anion happens to be carboxylate, right? And it's totally fine. This can definitely be a thing that you encounter. So you have to just go ahead and be able to number these molecules, be able to get the longest chain and name the carboxylate. So this is 5 carbons long. So this is known as pentanoate, right? So altogether, this is pyridinium pentanoate. So, just be ready for those type of things. These are the type of molecules that you might encounter. And yeah, some of the stuff is kind of borrowed from previous chapters. So, don't get tricked by that. All right, so in the next video, we're gonna then talk about some of the basic basic terms, the basicity actually of the molecule. So I'll catch you in the next video. Bye bye.